Hello students, so today let us start off with the part 2 of electricity and charge, chapter 1, class 12, physics. Now today I'll be starting with Coulomb's law. So what is the law states? Coulomb's law describes the electrostatic force between two stationary charged objects. So when there are two stationary charged objects, what will be the force applied by these two charges? So the Coulomb law states that. So mathematically, the force is directly proportional to the product of the charges. Directly proportional means if one increases, the other will also increase. If force increases, the charges increase. If the charge decreases, the force will also decrease. And inversely proportional to the square of the distance between them. So whatever the distance between them, that distance square is inversely proportional. So if distance increase, the charge will decrease. If the distance decrease, the charge will increase. So likewise, this is the proportionality sign. Force is directly proportional to the product of the charges Q1 and Q2 and inversely proportional to the distance between them, square of the distance between them. So Q1 and Q2 are charges and R is the distance. So F is directly proportional to Q1 into Q2 and inversely proportional to distance square, that is divided by R square. Now when I am removing proportional sign to equal to sign, we give a constant K. So F is equal to K mod Q1 into Q2. Why the mod? Mod symbolizes that the result will always positive. So F force equal to K within bracket within mod Q1 into Q2 product of the charges divided by R square. So this Coulomb's law was derived experimentally by Mr. Coulomb with the help of torsion balance. So what is torsion balance? It is a device by which Coulomb measured the force between two charged objects which formed the Coulomb's law. So basically the object have a needle, a charged object and a scale which is in the periphery. So Coulomb observed that when there are two charges, charge A and charge B, with distance r, so like charges repel, so there will be two forces, one moving this side and one moving this side, one moving to the right, one moving to the left. This force is applied on B by A charge. This force is applied on A charge by B charge. So we will be writing force B on A, force B by A, and this is force A by B. He further observed that when the distance decrease, the force increase, inversely proportional. And also he observed when the charge increase, the force also increase, directly proportional. Coulomb's law is an experimental law. So it is derived with the help of an experiment. Coulomb used torsion balance for measuring the force between two charged objects. Now this is very important. Value of K, that is constant, is equal to 9 into 10 to the power 9 n m square by c square. N is Newton meter square by Coulomb square. Now suppose Q1 equal to Q2, charge 1 equal to charge 2 equal to 1 Coulomb. So Q1 and Q2 is 1 Coulomb. And R is equal to 1 meter. So two charges are at a distance of 1 meter. So this means that 1 Coulomb is a charge that when placed at a distance of 1 meter of another charge of same magnitude. Magnitude is strength. The strength of the charge is same. It experiences an electrical force of repulsion. And the charges are same, hence the force is repulsive. And what is the force magnitude? 9 into 10 to power 9 Newton. So next topic of discussion is permittivity of free space. What does this mean? Permittivity of free space is a physical constant that reflects the ability of electrical field to pass through vacuum. So it's the ability for the electrical field to pass through vacuum. So a constant K is 1 by 4 pi epsilon naught. This E needs with a naught is epsilon naught, where epsilon naught is the permittivity of free space. The value of epsilon naught. So what is the permittivity of free space? 8.85 into 10 to the power minus 12 Coulomb square per Newton square meter, Coulomb square per Newton's meter square. So Coulomb square divided by Newton meter square. So we can write value of force equal to K. Instead of K I can write 1 by 4 pi epsilon naught into product of the charges Q1, Q2 within mode divided by distance square, that is R square. So next topic of discussion is Coulomb's law in vector form. So when there are two charges, there is a force on opposite direction, and we get to find the magnitude of force as K within mode Q1 Q2 by R square. So with this formula we can find the magnitude of force. Now to find the direction of force we have to represent Coulomb's law in vector form. Let us understand the way of finding the direction of force. So suppose we have two charges Q1 and Q2, and we need to find the position from the origin. So this is the origin. So what is the position of Q1 from the origin? We draw a vector line. We draw a vector from the origin to this point. Suppose this is point 1. And we name this line as vector R1. Also, to find the position of charge Q2 from the origin, we draw a line from the origin to point Q, to point 2, and we name the vector R2. Now we will find the distance of two charges, distance between the two charges. So far we have got R1 and R2 are the two vectors from the original position. Now we will be calculating the distance between two charges Q1 and Q2. So from Q1, where the distance is flowing from Q1 to Q2, it is called displacement vector and is denoted by R12. When the distance of charge from Q2 to Q1, the flow of vector arrow will be from Q2 to Q1, and it will be denoted as displacement vector R21. So I'll be reading what has been written. Distance from Q1 to Q2 is called displacement vector R12, and distance from Q2 to Q1 is called displacement vector R21. Now the charges are similar, so there will be forces, the repulsive forces, one force going towards the forces of repulsion on the opposite direction. Here the force will go down. This force is on charge 2 due to charge 1. This force is going up. This force is due to charge 2 on charge 1. So F12, force 1 due to 2, is force on charge 1 due to charge Q2. Force 2-1 is force on charge Q2 due to charge Q1. So let us sum up what we have learned so far, and we have got two vectors with magnitude and direction. So what we have understood, there are two charges and the distance from between Q1 to Q2 is R12 and from Q2 to Q1 is R21. Force is force on charge 2 is force F21. Force on charge Q1 is force 12. Okay. Using Coulomb's law now, force 12. So force 12 will be constant into two charges product Q1 into Q2 divided by distance. What is distance? R12 square into this is R21. This is 12, force 12, the force is going this way. So the distance is 21. So distance is R21 square into R21 unit. So this is a unit vector. What does this unit vector symbolizes? It symbolizes the distance. Similarly, force 21. Force 21. The force is going this way. So distance will be this 1, 2. So K Q1 Q2 divided by this will be square R12 square. R12 square into unit vector. That is the distance. So now if we want to write R12 and R21 vector in terms of the position vector R1 and R2, we use a vector addition triangle law. So the law states that if two vectors are represented by two sides of a triangle taken in order, then the vector sum, that is the resultant, is represented by third side in the opposite order. Let's understand this charge Q1, this charge Q2. From the position, from the origin to the charge Q1, it's R1 vector. From charge Q1 to charge Q2, distance is R12. Their sum will be the third side of the result of the triangle, which is the resultant vector, and its order is different. Its order is opposite. See, the order here is continuous, and here the order, vector order, is opposite. So we can write the statement as R1 plus R12 equals to R2. So R12 is equal to R2 minus R1. Similarly, if like from the origin to Q2 charge, it's R2. From Q2 charge to Q1 charge is R21. The resultant of the sum is R1. So we can write it as R2 plus R21 equal to R1. So R21 equal to R1 minus R2. So let us write down all the four vectors which we have derived at one shot. So here are the four vectors F12, that is K into Q1 Q2 by r12 whole square into unit vector 1 2, f21 equal to k q1 q2 by r21 whole square into unit vector 21. These are the two magnitude and direction. Then r12 vector equal to r2 minus r1, r21 vector is r1 minus r2. So this brings end to the part 2 of electrical and charge, chapter 1. And thank you very much. If you're liking my channel, please do subscribe and send it to your friends so that everybody can benefit.